So, this is episode 8 of making a walking game character. I am for this serial using the ct.js game editor. Up to now we have made a character that walks around inside a box. And we have added a feeling of perspective by scaling the sprite up and down, depending on if the character is closer or further away from the viewer. If you have not seen the earlier episodes, you might want to look at them first. So, in this episode I want to add more copies of the walking character. With ct.js, objects are created as copies from a template. We have a template for our walking character, and we have created a copy using that template in the Create tab for the room that the character is walking in. To add more characters walking in the room, we simply make more copies in that tab. Each copy have a unique name, so we will have this Draug1, this Draug2 and this Draug3. We set the point where the object is created to different positions for each character. This is all it takes to add new characters walking in the room. They all act in accordance with the rules set up in the template. So the 3 characters walk around inside the box, and they have perspective scaling applied to them. That's all good and fine, except when the sprites overlap. Sometimes the character that should be behind another character instead is in front. This depends on in which order the characters are rendered to the surface. Items rendered later within a frame will be rendered on top of items layers rendered earlier. The order in which layers are rendered are sometimes called zeta order, meaning that this is a third direction in addition to the X and Y direction, which are the directions of the CD surface. In ct.js, the zeta order is called depth. Each layer or object will have a depth that will determine in which order they are rendered. A lower number means an earlier rendering and a higher a later rendering. In this case, we need to change the depth depending on how far away the character is in the false perspective that we have created. This is represented on the screen by the sprite's Y position. A lower value of the Y value means that the character is further away and should have a lower value for the depth. So a simple way to do this is to, in the template, under the Frame Start tab, set this depth to this Y, after this Y have been set for the frame. This fixes the layer problem. Sprites higher up will always be rendered before, and those behind sprites positioned lower down on the surface goes closer to the viewer. So, problem fixed. But there is another problem, and that is where 2 characters look like they are walking through each other, like one or both of them are ghosts, which would be fine if at least one of them is a ghost. But that is not the case here, so we want to do something about this. The first step will be to check if 2 characters are getting too close to each other, and if they do, set them walking off in different directions. This could be done in some different ways. The way I figured to do it is to do it in the Frame Start tab for the room. So we need to start by making such a tab. To check the distance between 2 characters, we can use a ct.js function for checking the distance between 2 points. Ct point U, point PDC, we use the characters this X and this Y position to have points to compare. If the distance is less than 20 pixels, we use the direction between the 2 points to make them walk away from each other. ct.js for 2 points returns the direction from the first point to the second point. Using this, we can make each character walk away from the other. We have 3 characters and 3 possible collisions, drag 1 and 2, or drag 1 and 3, or drag 2 and 3. So all we have to do is to check for these 3 collisions, and if they happen, set the direction for the characters involved in the collision. And when we run the program after doing that code, everything seems to have turned out all right. The characters avoid collisions, and the walking around seems to work just fine. Now, I have in this episode compared the top left corner of the sprites, which works okay when the sprites have the same size. If we had had characters of different size, it would have been better to compare a point at each character's feet. Okay, this will be all for now. Thank you for watching, and bye.